In this video, we're going to look at comparing unit rates now that we know a little bit more about finding unit rates, especially when we have complex fractions. So we're going to start by reading a problem, and then we're going to explore a few different ways we can understand finding and then comparing our unit rates. Jose's mother is trying to decide whether or not she should buy a 12-ounce package of coffee on sale for $7.50. She knows that she can buy the same coffee for $9 per pound. Which is a better buy? So let's take a look at this problem with a model of a double number line. So to find the better buy, we're going to compare the unit rate of each option. So in this problem, she has two options. She can spend $7.50 for a 12-pound package, or she can spend $9 per pound. The problem gives you one unit rate. So one of the unit rates is that she is spending $9 per pound. So for 1 pound, it's $9. We want to compare unit rates. The unit rates, they must be the same. So find the weight of the other coffee in pounds. So what this is saying is in order to compare unit rates, we must have the same unit of measurement. So in the problem above, we have ounces and we have pounds. So as the problem is right now, we can't compare those unit rates because we have different units of measure. So we want to convert our 12 ounces to pounds. Well, there is one thing we must know. So we must know there's 16 ounces in a pound. This is a common fact that is a good life fact to know. So to put in our memory to use that there are 16 ounces in a pound. So we're talking about 12 ounces. We can write that 12 ounces as a fraction. 12 over 16. The part over the whole, because we know there's a whole 16 ounces in 1 pound. Then that 12 over 16 can be simplified to 3/4. So remember, to simplify that fraction, 12 over 16, you have to have a number that will divide evenly into both. And we know that 4 would divide evenly into both. 12 divided by 4 is 3, and 16 divided by 4 is 4. So that's how we know it's 3/4 of a pound. So let's take these facts and let's look at them on a double number line. So you can see the first number line talks about the cost in dollars, and then the second number line talks about the pounds of coffee. Both number lines starting at 0. And then the next thing I want you to take note of are my red numbers on my number line. So I want you to notice the red numbers that are lined up. That's our 3/4 of a pound. So up right above the double number line where we converted that 12 ounces to 3/4 of a pound, costing $7.50. So this is talking about how much it costs for 12 ounces. So remember, this 3/4 of a pound was 12 ounces for $7.50. Find the cost of each 1/4 pound of coffee and then find your unit cost. So now what we're going to do is we're going to fill in our number line. So if you notice, our $7.50 and 3/4 of a pound are still lined up. But what we're going to do now is we're going to fill in those numbers to fill in our number line. So it starts, let's look at the pounds, starts at 0. We have 3/4, and then we can divide that rest of that number line by fourths. So 1/4, 1/2, 3/4, a whole. So when you're dividing that number line up, you want it to be the same amount between each section. So from the 0 to 4, 1/4 is a fourth. and from 1/4 to a half is another fourth. So you're going up by 1/4 each time. You want that to be consistently the same. Now let's take a look at the top. So the top of our number line is the cost in dollars. So if you buy 0 pounds of coffee, it costs $0. And we already have what the problem told us. If we bought 12 ounces or 3/4 of a pound, that would be $7.50 or $7.50. We can fill in the rest with $2.50, $5, and $10, using that same principle of we're going up by the same amount. Now, we don't have to necessarily go up by the same amount as the bottom number line. This top number line goes up by 2.5. So from 0 to 2.5, that's 2.5. From 2.5 to 5, that's 2.5 more. From 5 to 7.5, that's 2.5. And from 7.5 to 10 is also 2.5. So no, it didn't go up by the same as the bottom number line, but it consistently went up the same amount. Let's answer some questions to look at this question more in depth to see if we can make a connection. The top number line is divided into 3 equal parts from 0 to 7.5. And the bottom number line is divided into 3 equal parts from 0 to 3/4. How can you use this to find the cost of 1 pound of coffee? So I want you to go back, pause the video, go back to the previous page and take a look at those number lines and see if you can figure out how can you use this to find the cost for 1 pound of coffee. Go ahead and pause the video and write your thoughts down. So remember, with unit rate, our big word that goes with unit rate is to divide, because you're trying to find out how much it costs for 1. So because we know it's 7.5 or $7.50 with 3 sections, we can divide 7.5 divided by 3. And 7.5 divided by 3 gives us 2.5. So remember, the work that would go along with that 7.5 you would want to be a mixed number or an improper fraction. So that's 15/2 divided by 3/1. Remember, to divide, we keep, change, flip. So we keep 15/2, change it to multiplication, and then flip it to 1/3. And then multiply straight across. 15 times 1 is 15. 2 times 3 is 6. And then 6 will go into 15 2 times with 3 left over. And that simplifies to 2.5. So that's how we got 7.5 divided by 3 equals 2.5. So what that tells us is how much it costs for 1. So by dividing 7.5 divided by 3, because remember it was divided into 3 sections, this tells us how much it is for 1. Number 12 wants us to write the ratio that compares $7.50 to 3/4 pounds of coffee. So the dollars is 7.5. Pounds of coffee is 3/4. So now we have what we talked about in our previous lessons, a complex fraction. So what number 13 wants us to do, it wants us to write and simplify a division expression to find the cost of 1 pound of coffee. So it wants you to take this complex fraction from number 12 and actually divide it out, similar to what we did or what I showed you in number 11 in my pink pen. So pause the video and see if you can write and simplify a division expression to help you find the cost of 1 pound of coffee. So what this problem wants you to do is take the complex fraction from number 12, and we're going to write it horizontally. 7.5 divided by 3/4. We need to change that mixed number to improper fraction so we can divide. 7 times 2 plus 1 is 15/2. Divided by 3/4. We need to keep, change to multiplication, and flip. And we get 15 times 4 is 60. And 2 times 3 is 6. And 60 divided by 6 equals 10. So this tells us it's going to be $10 for 1 pound of coffee. So 14 now wants us to compare it. Which is a better buy? Is it better to get 12 ounces for $7.50? Or is it better to get 1 pound for $9? Pause the video and you decide which option will be better and explain why. So it would be better to buy 12 ounces of coffee for the $7.50. Sorry, I wrote that the wrong way. Let me erase and go back. So we determined the $12 ounces. It was $7.50, which means it would be $10 per pound. The other option would be to get the 1 pound, which remember 1 pound is 16 ounces. And that 1 pound, 16 ounces, cost us $9 per pound. So the better buy would be 1 pound for $9. Because if you got 12 ounces for $7.50, you're really paying $10 per pound. But you could go ahead and buy a whole pound and get it for $9. Number 15, if you started the problem by converting 1 pound to 16 ounces, would you get the same result? Justify your conclusion. So remember, at the beginning of this problem on the other page, we converted 12 ounces to pounds, and we said that 12 ounces was 3/4 of a pound. So what this problem wants to know is, instead of doing that, and we converted the 1 pound to 16 ounces and then found our unit rate, do you think we would have gotten the same answer? Pause the video and write down what you think and why. So yes, you would get the same answer. You would still get, no matter which way you worked it, you would still get that for 12 ounces, it's going to be $10 per pound, and that for a whole pound, it's $9 per pound. Number 16, can you compare any two unit rates? Explain. Pause the video and write down your answer and your thoughts to number 16. No. When you're comparing unit rates, the unit rates must be the same unit. So if you have two unit rates that you want to compare, you can convert one to the other unit and then compare. But if your two units are different, like in this problem we had ounces and pounds, those two are different, We had to convert one to the other before we could compare it. Or if you had inches and feet, we can't compare inches and feet. But if you convert so that they're both feet or they're both inches, that's when you can compare them. Go ahead and highlight number 17.